Okay, welcome everyone. This talk is one I put together kind of quickly here. It's called Exodist Toolbox. I go by Exodist on CPN, and I am a tool builder. I have found that my true passion when it comes to programming is building tools, especially tools that help to build other tools. And application code is fine and all, but building tools is my passion. And in this talk, I'm actually going to be presenting 3 different tools that I have built specifically to help me build yet more tools. First one up, I'm actually going to skip around here. First one I'm going to go over here is, let me start at the right slide. A tool called Importer.pm, which is sort of the counterpart of Exporter, but it works on the other side. So currently in Perl, usually to do an export, you use Exporter.pm, which is as old as time itself. If you're using Moose, it uses sub-exporter under the hood. There's also Exporter declare, which is ultimate overkill of exporting. And as a disclaimer, I wrote that one. But these tools all boil down to the same thing: defining an import method on a namespace that then injects methods or subroutines into another namespace. So what's the problem with this system? Well, first of all, you sometimes wonder, where did X come from? Did it come from this import or that import? We don't know. And what if you want to do more things at import? You have to handwrite your own export code as well as your custom stuff, or go through contortions to inherit from Exporter and call it with the right context, which actually is quite difficult. So, can we disconnect exports in the import sub? Yes, we can. Introducing Importer.pm. You use it this way. You do use importer, then the module you want to import from, and then a list of imports. So, for an example here, we use importer listUtil to import first. But in this case, we didn't want to use the name first because it would conflict with something, so we rename it to lu_first. And then we can just use it as lu_first. Then below that, use importer scalar_util and the all grouping, but with the prefix su_. And now we have everything that scalar_util exports, but prefixed with su_. Once again, avoiding conflicts in the namespace. So how does it work? Importer.pm recognizes and finds the typical package variables used by Exporter.pm and is 100% compatible with all Exporter.pm features. So if you have a package that defines export and export OK, it'll just work. You don't have to change anything. Importer can import from it. So what features does it add? First, you can rename your imports. You can prefix your imports or postfix your imports. You can define import and export groups. You can generate exports, and even more. So renaming imports, I already showed you on another slide, or actually I showed you prefixing. So we use importer, thing we want to import from, and we rename the import foo as foo. Prefix and postfix, this is what I showed you on an earlier slide. We're importing something and we're adding the my prefix. And you can do this in bulk to a whole set of imports. Generated exports. This is some additional functionality that Exporter.pm did not have at all. You can specify exports that will be generated when you bring them into your package, and they'll know what package they're going into and what symbol name they're going to have, and then you return the reference that will be injected into the namespace. Anonymous exports. These don't even need to be defined in your package. You can just generate them on the fly here. This way you don't have your namespace cluttered with the things you're exporting. Importer menu. If you are doing some really complicated things that you want exported, you can define this menu instead of the global variables. So here I put the global variables on the right to represent what they would be in other export tools. Once again, those last two are exclusive. You pick one or the other because they both fulfill the same role. Bonus slide. Importer.pm is extremely fast. In fact, it is faster than Exporter.pm doing the exact same job. But in order to get it that fast, I had to write this mess. This was done using the profiler to find out exactly what things were slow and using really nasty language tricks to speed them up. So I'm half proud of this code and half disgusted by it. Okay, next tool I'm going to be covering is, let me go to the top, is Atomic Pipe. This tool I specifically wrote for the next iteration of Yath that I'm going to be releasing, because Yath runs a lot of tests, all of which need to send their output back to Yath itself. And I found that managing this was a pain. Currently, Yath uses temporary files that then get read by a different consumer, and it's a lot to manage. So I did some digging, and I found out that the POSIX specification for pipes says that any write to a pipe that is less than the size of pipe buffer will be atomic, which means no matter how many writers are trying to write to that pipe, as long as their messages are below a certain size, they will not get mangled with each other. So I already largely covered this. What problem is it solving? In this case, I have a lot of writers that are all trying to write to the same consumer. And this allows me to create a single pipe from the reader's perspective that all the writers can write to at will. So this, like I said, it uses the POSIX specifications to get the job done. Under the hood, it will do the hard work of making sure that your data is sent in atomic chunks and then reassemble them on the other side. So implementation details. There are three concepts, two concepts here that I'm covering. There's a burst, which is a chunk of data that is already the correct size. And there's a message. It can be any size. It can be huge, and it will be sent as one or more bursts. Each chunk of a message is sent with a header consisting of the following: process ID, thread ID, part number in descending order, and size of the chunk in bytes. So here's the interface. Use Atomic Pipe, create your reader and writer with Atomic Pipe pair. Then in this case, worker is a subroutine, or is it's a sub that will run that block in another process. So think of this as fork that does a lot of the work for you. And in that writer, we're sending data. And then when we want the message, we just say, hey, give me the message. But there's also mixed data mode. Mixed data mode is where you expect any number of workers to send a combination of line data, atomic bursts, and or long messages. Line data would be if someone just prints to the pipe. In this mode, a burst starts with a special character, the shift out control character, and ends with the shift in control character. Messages are bursts that have the data link escape at the very start of them. Most of the time, these characters will not conflict with anything that you need to send, unless you're sending binary data, at which point you're going to have to encode it first. But with this, you have everything you need to reconstruct regular lines that were printed, bursts, and messages. So no, not the original use of these characters, but close enough that it makes sense. So, big long example here, our worker is opening the write handle to standard out, and then it's printing to standard out. First a line that ends with a new line, then a line that doesn't. Then it writes a burst, and then it writes large data, and then it prints another line, but with the new line. Then when we go to read, we have this convenient method, get line, burst, or data, which will get whatever's next in the queue. So the first thing we get is that first line that was sent. This is just the text being sent, not atomic. Next one that comes through is our data burst. Then we get the large data, and then we get the two halves of the line that was buffered because new line was not attached to it. That's this two, ... more dots, and terminating new line. With this, it becomes very trivial to send messages between processes, even multiple processes to one consumer, without getting your data interleaved and mangled. So what's it used for? As I said, I wrote this specifically for the next iteration of Yath. In the next iteration of Yath, the tests will start running with one atomic pipe on standard error and one on standard out. That means any regular prints, any diagnostic messages, they will just continue to work with standard error and standard out as though it were a regular pipe. However, test 2 under the hood will know that this pipe is there, and any testing events, such as OK, diag, whatever, are going to be sent as JSON lines, as JSON data, as a message across. And every time a message goes out, both file handles will also receive a burst with the ID of the event, which means standard error, standard out, and your events can all be synchronized in time. You know what order they come in, which is something that Prove, if you haven't noticed, has a hard time with, where your standard error and standard out might be in different places. This is actually something Yath already does, just not quite as sophisticated as what it will do with this. That version of Yath is not out yet, but it will be hopefully soon. Bonus slide. This works on Windows.
Yeah.
Note I found while doing this, BSD pipes are bidirectional. Atomic Pipe also provides you with an interface to adjust the pipe buffer size. And interestingly enough, the pipe buffer size and the pipe buff constant here, they're not actually related, which is really strange. Last tool I'm going to be presenting on real quick here is DBI QuickDB. I wrote this because I was really tired of reinventing the same database code every time I was writing tests at different places. And sometimes you just want a database and you don't care about configuring it or starting it or anything else. So with QuickDB, all you have to do is load DBIx QuickDB, specify, hey, I want a MySQL database, or I want a Postgres database, or SQLite, or whatever else. And it'll just give you one. It'll spin up MySQLD, it'll spin up Postgres, it'll give you a blank database, and you can do whatever the heck you want with it. And when your code exits, the datadir is destroyed and the daemon is killed. This way you don't need a system-wide one, you don't need a central server for your databases, you just get the database you need. It's got a lot of options. I'm short on time, so I'm just gonna briefly go over them here, but you can auto start, that's default. You can give it a dir. So if you've actually already got some database data you want to start on, you can do that. You can tell it whether or not to bootstrap, default as it will. And you can also specify, hey, I want a database of this driver. Or if you're feeling lucky, you can say, hey, just give me a database and you'll get whatever first driver it finds that works. Don't recommend that one, but it's there. You can write custom drivers. Currently, we've got Postgres, MySQL, and SQLite. They all work by subclassing the DBIx QuickDB driver class, and all three are great examples if you're looking to add a driver. There's also Test2 Tools QuickDB, which are handy testing interfaces for getting your databases. In this case, we've got like a getDB or skip all. That way you skip your test if you say you don't have MySQL installed on the system. But the real magic here is the database pools. This is where you can define a pool of databases, say, in this case, Postgres is our driver. Then we have a step for building the schema. Then we have a step for building scenario A and a step for building scenario B, which in this case is actually built on top of scenario A. Then in, say, your test, you can say, hey, I want this pool. Give me a database for scenario A. First time you do this, it will start Postgres. It will populate the database. It'll run your build method to further populate that database. It'll do it for all the databases that are a dependency of that one. Then it will kill that daemon, but keep the datadir. And then it will clone that using rsync if you have it. Otherwise, it uses some pure Perl to do it. And then it'll start a new daemon on that copy of your datadir. That takes like 3-4 seconds. Then every time you need a database with that scenario at its beginning state, just takes 3 seconds to rsync that datadir and start a new daemon for you. So it's basically a caching of all the layers of database that you might need for your tests. I have used this in a few places now to support running hundreds of tests at the same time that all need databases without needing a central database server. They're just spun up and destroyed as needed. And the caching really helps because in some of these cases, some of the scenarios could take up to 5 minutes to generate. And so we had tests that would take 5 minutes before they'd even start making assertions. But because of this caching layer, all the tests that use that same database state, that same scenario, just instantly, 5 seconds after the first cache is built, get their databases, greatly reducing the amount of time. And in cases where the tests had data servers, central servers, if they were getting overwhelmed by hundreds of tests, we don't have that problem anymore. You get a beefy enough server, you can run hundreds of these databases all at once. Bonus slide. I think I actually talked about most of the stuff on this bonus slide before switching to it. So that is all three of the tools that I wanted to present today. If anyone has any questions, I'm ready for questions and answers. Yes?
Do I have to use a modern Perl, or how far back in the past do you support?
I think these all work on 5.10 plus. Some of them might work all the way back to 5.8. Some might use a feature of 5.12. I really don't remember, but you can look at the packages. Yes?
For the pool, it might be interesting to say, go ahead and pre-create this many of this particular database thing, because we do have instances where we want to be able to use a whole bunch of tests into parallel and not even wait 3 seconds per test, but automatically have something ready. And then when it's done, discard it. But then it knows, okay, it's discarded, I'm going to go ahead and create it.
So I do actually have that not already written as something on CPAN, but Grant Street Group, where I work currently, our YATH settings, our YATH integration has YATH spin up the databases while it's preloading the application before spawning any tests. That's an easy integration to write. It'll be even easier when the next version of YATH comes out in the coming month or two.
And how do you handle the case when you need a particular type of, say, PostgreSQL, an older version, which maybe not supported anymore, but your client needs?
That's probably something you and I should talk about separately after this talk. Yes?
For atomic pipe, in your experience, what size is the atomic size? Is it like really small, or is it like a K or something?
If we actually go back to that. The question was, what is the size of the atomic pipe in general? The POSIX requirements say it must be at least 512 bytes. On Linux, in my experience, I've always experienced 4K. So generally, for most simple things, it's enough. If you've got a really big message, it will be split up.
But that's a pretty good amount for simple message.
Yes, and Atomic Pipe, I did add for sufficiently high enough versions of Linux, you can actually set the pipe buffer size. And there's an interface to do that on Atomic Pipe, and it's a no-op if you do it on a Linux that's too old to support it. Questions on any of these modules? Okay, well, I hope you guys enjoyed that, and I hope you guys will pick up these tools. Once again, tool building is my passion. I even like it if people come to me and say, hey, can you help me build this tool? I love it.